Hey everyone, in this video we'll be talking about Chapter 6 of Dive into Python by Mark Pilgrim, which is about exceptions and file handling. Syntax errors are the errors you get when you use incorrect syntax, and they're caught when you're trying to parse that line. For example, a missing colon after an if statement. Even if a statement or expression is syntactically correct, it may cause an error when an attempt is made to execute it. Errors detected during execution are called exceptions and are not unconditionally fatal. For example, try this line of code in your Python interpreter. Do print 10 divided by 0. Even though the above line is syntactically correct, you will get an exception saying 0 division error, integer division, or modulo by 0. You can't divide a number by 0. It is possible to write programs that handle selected exceptions, and the methods to handle these exceptions are known as, you guessed it, exception handling. Okay, cool. So the syntax is as follows, and you can follow along here with me. In 1.py of the Chapter 6 examples, link in the description as always. The first part is the try keyword. This is the code that you're going to try to run. And if you enter some code that works without any problems, that's great. And if it does encounter a problem, then you have this next block here, which is the except, and that if the exception is caught, then this code is what will run instead. In this case, it'll say cannot divide by 0, or cannot divide by whatever you passed in as var2. Now you may ask, why don't we always use except without any argument? In that case, it will try to catch all types of exceptions, which sometimes you don't want to catch. Sometimes you only want to catch particular kinds of errors. And that's all right too. Once the exception is caught, the program will continue normally, assuming you escaped it all right. Another one to look out for is the IO error. This comes up when we try to open a non-existent file. You can use exceptions to do a lot of other tasks. Suppose you want to import a module. If you try to import a non-existent module, an import error is thrown. So if we say import yay, it'll say no module named yay. Let's take a look at the open file one as well. So there's no such file or directory called yay. So that's what that one looks like. Another thing you can do, check out 2.py. This is another method for catching errors. So you have the try block as usual. That's the code that you would like to run. And then the except as always, which is the error. And then else is where this is sort of the next part. The next part, if this is successful, if the exception was not hit, then you can do more code after that. And in fact, you should download this repository and be running these files through your own Python interpreter to sort of see what that looks like. So another one in 3.py is the try except finally block. That's a slight variation. Now that has the try and except, which we saw in the last several examples, but the finally block will run regardless of whether the try was successful or whether the exception was thrown. 4.py, this is where we have the IO error. This is all about working with a file object. That means opening a file, writing to it, saving it, overwriting it, appending it. There are so many ways that you can manipulate a file, and this is where we learn how to do that. So the syntax for the open function to grab a file and to make it accessible to your script as it's running is like this. You have open, and then you have the name of the file or the directory or a path to the file, and then the mode that you want it in. And then there's also an optional argument that you can pass for buffering if you want that available to you. That's a little bit outside of the scope of what we're talking about, and it's a little foreign to me too, to be honest. But that has to do with operations happening in memory as you're doing your reading and writing. There are several different modes that you can access a file with, and the first one is R. That's read, and that's the default mode, so you'll just be pulling information from a file with this. There's also W, which is exactly what it sounds like. It's write. It will overwrite a file if it already exists and create a new one if it doesn't. R plus as the argument for mode is read write, and the pointer is at the first position of that file, so that will be prepending anything to what you already have in that file if it exists. Conversely, A is an option to open a file and add whatever you're writing to the end of the file. W plus is write read, which is open file for read and write, and overwrite the file if it already exists, create it if it doesn't. And apart from this, there is a binary mode which deals with files in binary format. So buffering is the size of a buffer, as I was talking about a minute ago. If buffering is 0, then no buffering will take place. If buffering is 1, then line buffer will take place. And if buffering is greater than 1, then the buffer will be the size as well as the value that you pass in. And like I said, this is about your work being stored in memory as it's written. So, but for our case here, we're just reading the file, and that's passing the R. In 5.py, we're looking at writing to a file. So assuming you've opened your file and it's accessible in your program, you have that ability to append or prepend depending on what you want. In this case, we're going to be writing, and this is basically the syntax for how you'll do that. It's using the write method, and then it's saying, okay, this is what in particular, this S that's getting passed in, this is what's actually getting written to this file that we opened up here. It's worth noting that in W mode, a file will be created if the file already exists, if foo2.txt already exists in our directory, it'll get deleted, and this action that happens on line 1 will create a new file that's empty. Conversely, if we had given it an A, which is for append, of course, that will just be adding new lines to the end of the file. So last but not least, we'll be looking at the system module, and you can follow along here in 6.py. The sys module contains system-level information, like the Python version you're using, maximum recursion allowed depth, and just tons of other stuff, tons of other information about the environment that you're working in. So if you do print.sys version, you'll get this, and if you do sys.getRecursionLimit, you'll get 1,000. And recursion, though outside the scope of this video, basically is when you call a function inside itself, which is kind of crazy to think about, right? It's turtles all the way down, just functions inside functions inside function. It's really cool, very powerful stuff. But back to the sys module. So it's a dictionary which contains the information of the modules that have been imported since the program or interpreter started. And so if you do like print sys modules, you get a lot. A lot has happened here. To work with file and directory level information, you have to understand a module called OS. The OS module has several methods and functions defined, which makes OS-related tasks easy to complete. os.path is a module which has several functions for manipulating files and directories. So you can do os.path.join, and then that will take a path to a directory and a file and put them there, put them together. It's different for different operating systems, but that's pretty easy to look up. os.path gives a reference to module, and then with that reference we can call a join method which constructs a path name from one or more partial path names. You can use os.path.expand user to get the home directory of the current user. If you're using any flavor of Linux, this should be pretty familiar to you. os.path.split with a path to a file name, or with a path to a file, we'll split the file name and the path to it into two partial path names. And there's a couple more things here in 6.py that I would encourage you to take a look at and play with. mkdir is make directory, and that'll make a new folder wherever you are. chdir is change directory. Get cwd is get current working directory. So there's a lot of good stuff that you can use to see where you are, to move stuff around, and so on. So that is about it for Chapter 6. I hope you enjoyed it and found it helpful. Let me know if you have any questions, and I'll see you all in the next video.